And I am a master's student at UW-Madison, about 3 hours north of here. My advisor is Dr. Aaron Silva, and the title of my presentation today is Organic Alternatives to Conventional Celery Powder as a Meat Curing Agent. So, celery nitrates can be used as a natural curing agent. It's in the family Apiaceae, the carrot family, has a long growing season, 70 to 120 days to maturity. It's consumed worldwide, fresh, processed, as an ingredient or as a medicine. On the left, on your right, you can see three anatomical zones of the celery plant. The bottom section is the crown, the middle section is what's considered the stem or the petiole, the upper section is the leafy material. And for our purposes in processing, we use the upper two sections. So as I mentioned, celery is a known nitrate source and accumulator. And this celery is juiced, and then at the meat processing side, the juice is converted, concentrated, and applied to those meat products in solution or powder. So why celery nitrates? So a lot of the previous presentations mentioned that synthetic products are unavailable to organic farmers. So this includes sodium nitrate, potassium nitrate. Those are unavailable to organic meat processors. And there's a current lack of natural nitrate sources. So natural, I mean from a vegetable, but not necessarily organic. There are very few organic vegetable extracts that can be used for this purpose. Conventional extracts are okay right now because of that technological barrier. So that's what we're working on. We're trying to develop methods to produce an organic celery extract that can be used in organic meat processing. So moving into my research objectives to address the market need in organic meat sector, we're focusing on the following objectives to see how each affect nitrate yield in organic celery. In this presentation, I will be focusing on the first objective, which is assessment of timing, rates, and sources of nitrogen fertility affecting nitrate yield in celery. So this is a replicated experiment. My first field season was last year in 2021. We used a split plot randomized complete block design with the whole plot factor being the 5 nitrogen treatments, 0, 120, 180, 240, 300 pounds of nitrogen per acre. And our split plot factor was a cover crop consisting of 50-50 mix of field pea oat by weight. And the field location was at the West-Madison Agricultural Research Station in Madison, Wisconsin, situated in USDA Grow Zone 4 and 5, and the soil is a silt loam, and this is organic certified land. So some background on organic celery cultivation in south central Wisconsin. Planting can occur two ways. You can direct seed late April, or do as we did. You can take transplants and plant those into the ground in late May, early June. We worked with an organic greenhouse that grew out our transplants, so the whole cycle was OMRI approved, and then we transplanted around June 1st of 2021. Our spacing, space between plants within a row was 8 inches, and then between our rows we had 30-inch spacing. Our soil amendments, which were our nitrogen treatments, was 1300 feather meal, and the oat pea cover crop, which counts as like a green manure. And then our irrigation, you can see we used above ground drip irrigation here is a 5/8 inch tube with 4-inch spacing emitters. Fertilization, all of the fertilizer amendments that I just mentioned were incorporated pre-plant. So before the celery went into the ground, the cover crop was terminated, tilled in along with those feather meal treatments. Pest and disease management, we know it's challenging in organic. So at this stage, we're really monitoring for what pest populations are out there and how nitrogen rate might affect those pest populations. And then we're also trying to mitigate disease pressure by being, watching what we could introduce to the field, by heat treating the seeds, for example. Harvesting, we harvested 3 different times, approximately 30 days from transplanting, 60, and then 90. And at the 90-day point, we did a final harvest where we also measured fresh yield, diseased yield, and then lost yield by weight. So how do we get the nitrate? After we harvest petioles from the celery, That's a detail that I neglected to say. When we harvest, we take a couple petioles. So we're not taking the whole plant at soil level. We're taking a couple petioles, and then at final harvest, we'll be taking the whole plant. So we bring those petioles back to the lab, and we juice them. And this process we try to do as soon as possible to limit that nitrate decomposition or conversion into nitrite. And we freeze the juice until nitrate analysis, and then it's at a stable state then. And then we thaw and prepare the samples and measure the nitrate parts per million using two different methods. We use the NitroCheck 404 reflectometry method and the ENO 20 HPLC method. And the next steps, then the juice goes out of our lab and down to the meat science department where the juice is fermented for meat processor application. So busy slide, but moving into our results, we had to confirm that our data met the assumptions of ANOVA before we could analyze it. Our biological hypothesis was treatments incorporating both cover crop and high amounts of the feather meal treatments will result in organic celery tissue with highest levels of nitrate. Our statistical model is below in statistical notation as well as in R notation, the software that we use to analyze the data. And then the analytical steps are below, again, just making sure those assumptions of ANOVA are met at each of those steps. So looking at our first year of results, so significant differences in nitrate yields existed between harvest dates. So that visual is not shown, but then we broke it down and looked at each factor on each harvest date, and those are the results that you're seeing here. So our three harvest dates were July 6th, August 5th, and August 31st, 2021. We did not see any significant differences between the cover crop treatments, and we did not observe an interaction that year between cover crop and treatment. We did, however, see a strong treatment effect across harvest dates. So in short, the nitrogen treatment had a significant effect on the nitrate yields. These are visual results of what I just presented. So you can see on July 6th here, we had our highest nitrate yield. And then over the season, all the way up to our final harvest on August 31st, those nitrate yields dropped within the treatments. They trended lower over time. And our treatments are on the x-axis here, 0 to 300. And then on the y-axis, you can see the nitrate parts per million. And you can see kind of a yield curve going on, and that's what I'll explain in my next slide. We're not seeing a significant effect after 180 pounds of nitrogen. For mean separation, we use Tukey's LSD with a significance level of 5%. And as I was just saying, we found no significant differences between the 180, 240, and 300 pound treatments. So what is that saying to farmers? That's saying, you're not getting any additional benefits from applying greater than 180 pounds. At least for 2021, we're analyzing 2022. We also found no difference between the 0 and 120 nitrogen treatments. But overall, the nitrogen yields, again, they trended higher with the nitrogen treatments, with the higher nitrogen treatments. So in conclusion, going back to the objective that I'm covering today, we looked at the timing of fertilizer application, the rates of the application, and then the sources. So I'll go over each of those elements of the objectives now. So for timing, we found that the greatest tissue nitrate yields were recorded at harvest 1. That was 30 days from transplanting on July 6th. Nitrate yields gradually decreased within treatments over the season. Looking at the rate part of our objective, an increase of nitrogen application increases nitrate yield to a point. Those higher treatments were not significant from each other, so these data are suggesting diminishing returns of nitrate yield when greater than 180 pounds of nitrogen are applied. So sources, there was a strong nitrate yield response to the feather meal treatments. However, there was no effect of the cover cropping treatment, which could have been a source of nitrogen. We saw no observed significant effect in 2021. Moving into the discussion section of the paper, in 2021, we had a spring drought, so our cover crop emergence was extremely limited, and it was mostly oats. As I mentioned, it was a 50-50 mix by weight, so you can picture, a pea seed is much bigger than an oat seed, and so we had mostly oats instead of peas, which would have been contributing and fixing that nitrogen. So cover crop did not seem to affect nitrate yields in 2021. Further research is warranted to analyze disease risk. As I mentioned, we're looking at disease management within organic celery. One big issue we had last year was a high incidence of rot pathogens such as anthracnose and pectobacterium. So one thing we did to mitigate this year was we did a hot water bath of the seed treatments of the seed before we planted the transplants. That doesn't limit any inoculum that's latent in the field from past rotations, but we're at least trying to mitigate what we're introducing. So we did observe nitrate yield variation within treatments. So the yields trended upwards of the 1,000 parts per million within treatments, and that could lead to inconsistencies within a treatment, and then that causes issues in the meat science, for meat processors who often desire a minimum yield for conversion efficiency. So they might say to the farmer, we need 5,000 parts per million nitrate, or we're not going to give you the most money for your crop. So we want to make sure that we explore these yield variations within treatments as we're making these management recommendations. And as I mentioned, this study is currently being replicated in the same location, a different field, but we will compare those results to the 2021 data. Finally, I'd like to acknowledge my advisor, Dr. Aaron Silva, and our team at University of Wisconsin. The undergrads that we have helping us are amazing. The West-Madison farm team, where would we be without the people, tilling the field, running the equipment? We really appreciate them. Our industry partners and our partners across UW, and then finally our collaborators here today, Dr. Zin Zhao and Zachary from the University of Florida. This work is funded by a USDA NIFA OREI grant with the same title as the presentation today. And with that, I'd like to thank you for coming and listening, and I'll take any questions or comments. Thank you. Yes?
Was your nitrate yield, was that in concentration, or was that actually yield of nitrate per acre?
Yeah, so that's a great question. The question was what about our nitrate yield? Is it in concentration or by weight? So it is in concentration. I need to use the formula that I was given to convert it to a milligrams or grams per hectare basis. Yes?
As a follow-up, do you think that the reduction you saw was simply the initial concentration being reduced by water as the plant got bigger?
Yeah, so that's another good question. We're looking into the question was, how can we explain that drop in nitrate yield over time? Was it due to water? And our irrigation regime was very judicious. So I would hesitate to attribute it to irrigation. Instead of a lot, weekly applications, we would do, 3 times a week to try to limit that nitrate leaching. I think it's more attributed to the front loading of nutrients. There are many farmers that use side dressing applications instead of all front loading nutrients, but our previous research shows that had no added benefits for this purpose. Yes?
Do you think that there could be any effect from the petiole removing in your sampling technique?
Yeah, definitely. So it's, yes. Yeah, so great question. So the question was, are we affecting the nitrate yield by removing parts of the plant? And I would say yes. It's destructive harvesting that we do, and certainly a lot of that nitrate is going towards the biomass up until maturity. So what we've done is just tried to standardize it. What we do is we take the second most outer petiole. So celery grows in a rosette, and we're trying to select not the oldest, most succulent material, but the second to oldest, and then leaves that newer growth inside so it can stay like a tight canopy. But further work should be done there to look at biomass related to nitrate yield. Yes?
What was the deciding factor to decide on what's harvesting time?
So we selected based on feasibility. So just sample processing time and time it takes to harvest. We wanted to, say 30 days, and then, have the crop in the field for a total of 90 days. It was just a good number to pick to kind of measure how the nitrogen was getting into the crop. Yeah, so the question was, what was the basis on, picking 30 days as opposed to 40 days? So we wanted to catch, we're limited as in we have to plant the celery, or I'm out of time, so I have to stop. I'm sorry.